Today let's look at the LeetCode problem 199, binary tree right side view. Now you are given a root of a binary tree, and imagine yourself standing on the right side of the tree. Okay, right side of the tree. Return the values of the nodes you can see ordered from top to bottom. So imagine that you are seeing this. Let's just dive a little bit deeper here. So imagine that you are seeing your tree from the right side. So when you are seeing from the right side, you will have to return the elements from top to bottom. So your output will be 1, 3 and 4 in this particular tree. Let's take a slightly more complicated use case. Here if you see, in cases where you don't have right nodes here, then you would be actually now in this case returning 1, 3, 4, 5. One way to solve this problem is using breadth first search or the level order traversal. And then what we can do is on each level always return the last element. Not return, basically push it into the array, the last element at each level. Now let's see how to code this up. It's much easier to explain this using code. Now let's try to code this up. To start with, we will first do a breadth first search or a level order traversal. So I will just take a handle the corner case where root is null also. So this will be if it is null pointer, we can just return an empty array. Then in the level order traversal, let's create a queue of tree nodes because it's needed for traversing the tree. So and we'll just push the root element to start with. Now let's start the level order traversal. While queue is not empty, let's iterate through the queue. So now let's first try to get a level order traversal int. So I'll take the queue size. This is needed to ensure that we only traverse the nodes in the current level. So we will just go through I is equal to 0, I less than queue dot size. The idea is that we will be inserting more nodes of the next level. So to avoid us parsing through that in our for loop, we will just take only iterate through the queue up to the queue size in that level. So here we go. Then we'll now first take the current node. So this is basically our normal level order traversal or breadth first search traversal. So we will take the queue dot friend and we'll do a queue dot pop. If cur of left, we'll just insert that one. Queue dot push cur of left. If cur of right, so if there are there is a right child, we will just push that also. Cur of right. Now if you see one thing interesting here, so this will give us the level order traversal. Now if you see one interesting thing here, in all these cases the last element in each level is what you will see from the right side. So the same here. In this level 4 is the last element. That will be the element that you'll be seeing. Imagine you had a 6 here, then you would have been seeing 6 here, and that would be the last element in the queue. Now let's go back to the code. So what we can do here is I can always check. This is one way of doing it. If I is equal to queue size, or -1, then I could just push this in an output array. Okay. Well, out, and you can just return out. If you want to make it a little bit more, avoid this condition, what you can do is every time store it in the rightmost element. So you could even do this where you have it as this way. Let's put it as something like in max. Okay, and anyway you will iterate through because queue is not empty, so we can just put rightmost equal to current file. We could even keep this as a safe value. Okay, then let's see whether this works. Then I don't need this condition. Okay, let's see. And of course here you will have to out dot push back rightmost. Let's see. So this looks okay. Now let's see, try submitting it. Yeah, this looks okay. Then the time complexity will be, let's put it here. Time complexity will be order of n, because you have to parse through each element. Since it's a level order traversal, and you could have n in a perfect binary tree, you could have n by 2 elements in your last level. So our space complexity also will be order of n. So that's it for today. Thank you.